Adding and subtracting rational expressions. First, we're going to talk about the least common multiple, or LCM. To find the least common multiple of two or more polynomials, factor each expression. The least common multiple contains each factor the greatest number of times it appears as a factor. So what does that mean? It means it's the highest power of shared factors and anything that is not shared, if that makes more sense. So we're going to find the least common multiple of the following. So the first thing you want to do is break this down and write it as the prime factors. So if I break this breaks down into, and of course there's other ways you can break this down, but 2 and 12. And 12 breaks down into 2 and 6 breaks down into 2 and 3. And 4 breaks down into 2 and 2. So if we write this as the prime factorization, this is 2 times 2 times 2 times 3, so 2 cubed times 3, and then we have a cubed, and this one over here would be 2 squared times a. So if we're going to look at the least common multiple, again, it's the highest powered of shared factors. So if we look here, we have a 2 to the third and 2 squared. So the highest powered of shared would be 2 third. So the LCM is going to have a 2 to the third. And then this has a 3 and this one doesn't have a 3. So anything that's not shared, so times 3. And then here we have a to the third and a, so the one that is the highest would be a cubed, so a cubed. So this would be my LCM. We just need to multiply this out. So 2 cubed is 8. 8 times 3 is 24. So the LCM is equal to 24a cubed. And so that means that both these are divisible by 24a cubed. So then over here, same thing. So 18 breaks down into 2 times 9, and 9 breaks down into 3 times 3. And then 24 we just did, so I'm just going to use what we did on the other side, make it go a little faster. So here we have 2 times 3 times 3, so 3 squared, a cubed, b, c squared. And for this one, we know 24 we just said was 2 cubed times 3. And then we have the b squared, c squared. And so again, you're looking for the highest powered of shared factors. So here we have the 2's. So this is 2 to the third and 2. So that means our LCM, if we have 2 to the third is the highest, that means we need 2 to the third here. Then we have 3 squared and 3, so times 3 squared, because that's the highest power to shared. Here there's an a cubed, but there's none on this side, so that means we need a cubed here. We have a b and a b squared, so the highest would be b squared. C squared and c squared would be c squared. So then anything that's numerical, we just need to figure out what that's equal to. So 2 cubed is 8, and 3 squared is 9, so 8 times 9 is 72. And then we have a cubed, b squared, c squared. So why are we doing this? Because we're going to want to find the LCM for now more than just one term. So when we have polynomials. So looking at this first one, we have a binomial. There's 2 terms. And so if I want to find the least common multiple, I need to factor this. So I first want to look for my greatest common factor. So 4 goes into both of these. So 4 times x squared minus 9. And then we have 2 terms. This is squared, and we can take the square root of 9, and it's a minus, so we can do the difference of 2 squares. So 4 times x plus 3 times x minus 3. And of course, we can write 4 as 2 squared, so we'll go ahead and do that here. And on this side, same thing. So first look for the greatest common factor, which is 6. X squared plus 6x plus 9 is when we take out that greatest common factor. And then we want factors of 9 that add up to 6 would be x plus 3 times x plus 3. And then of course 6 breaks down into 2 times 3, and we can write this as x plus 3 quantities squared. So then the LCM, we have 2 squared and 2 here, so 2 squared. We have a 3 here, but none here, so we need a 3. And then we have x plus 3 twice here and once here, so we need x plus 3 twice, and then we need an x minus 3. So then anything that's numerical we can go ahead and multiply out. So 2 squared is 4 times 3 is 12. So the LCM is 12 times x plus 3 quantity squared times x minus 3. Looking at this one over here, we have 5a that doesn't break down at all, and a minus 1 also does not factor into anything. So that means your LCM, we have 5 times a minus 1. Remember, when you have an addition or subtraction sign between terms, that means those go together. You cannot separate them. So sometimes students try to write just one a and then the minus 1, but you need to write the 5 times a minus 1. And that's for the least common multiple. So now we're going to apply this to add or subtract a rational expression. So to add or subtract a rational expression, remember you must have the same denominator. If the denominators are different, we want to factor and find the lowest common denominator, LCD, which is similar to finding the least common multiple. Multiply the fractions numerator and denominator by the missing factors to get the common denominator, and then add or subtract the numerators to combine like terms in the numerator, and then we are going to simplify and leave our denominator in factored form for now. So let's just go ahead and look at what we've done in the past. So we've done problems like this in grade school. So if I want to add these together, I need a common denominator. So we're going to go ahead and break these down. This breaks down into 2 times 3, and this breaks down into 3 times 3. So that means my least common denominator would be 2, and then if we have 1, 3 here and 2 here, what's the greatest time it appears in either? Twice. So that means my LCD is 2 times 3 squared, which is 9. So 2 times 9 is 18. And of course, this would have been an easy problem to see that we could have done without breaking it down, but this is going to help you for the next problems that we do. So then I look for, well, what's missing from my LCD from these denominators? This is 2 times 3, and this is 3 times 3. So this needs to have another 3, so we're going to multiply both the numerator and the denominator by another 3. And over here, what are we missing from the LCD? We're missing a 2, so that means this needs to be multiplied by 2 over 2, because what you do in the numerator, you have to also multiply in the denominator, so it doesn't change the equation. So then you multiply numerator times numerator, denominator times denominator. So 5 times 3 is 15, and 6 times 3 is 18, plus 4 times 2 gives me 8, 9 times 2 is 18. And the reason we did that is so that we would have this common denominator of 18. Now that I have a common denominator, I can combine the numerator over my common denominator. So 15 plus 8 is 23. And your common denominator stays the same. And of course, if you could reduce, you would always want to reduce. In this case, we cannot, so that is my solution. So if we look at number 2, notice the denominator is already the same, so that means my least common denominator is just a. So I don't have to do anything here except for combine the numerator over my common denominator. 6 plus 8 is 14 over a. Looking at number 3, again, my least common denominator is now 4x because they're already the same. So combine your numerator over your common denominator. Now for this one, you're not quite done because notice you have 10 over 4. Well, those are both even, so that we know we can reduce. So when we reduce this, 2 goes into both, so that's 5 over 2 times x. So always make sure you can look at your equation, and if you can factor further, always factor further if it's possible. So looking at question number 4, our least common denominator is x times y. So we already have a common denominator, so we just need to combine the numerator over our common denominator. So we're just adding our like terms. 2x plus 4x gives me 6x, and 1 minus 2 is minus 1 over x times y. And this does not simplify. Remember, you cannot cancel out those x's because we have 6 times the x minus the 1. If that minus 1 was not there, so if we had instead 6x over xy, then you could cancel out those x's and write 6 over y, but because it's attached to that 1, you cannot do that. So remember, we talked about that the other day. Looking at question number 5, my LCD is a, and then we also have a b here, so a times b. That means we need to multiply this by b over b. So we get 2 over ab minus, and this would be, we need to distribute the b to each of these terms. So xb minus 8b, and a times b is just ab. Now we have a common denominator. So now I can go ahead and combine my terms. Now you have to be careful because this is a minus sign here. So that means that minus sign has to be distributed to both of these terms. So 2 minus xb minus minus becomes plus 8b over your common denominator ab. And then there are no like terms here. So since there are no like terms, then we can go ahead and say this is our solution because I cannot simplify anything further. Looking at number 4. So for this one, we want to find the LCD. And in order to do that, the first thing we want to do is factor this second fraction. So it's a difference of 2 squares because we can take the square root of x squared and the square root of 16 is 4. So x plus 4 times x minus 4. So that means these already have a common denominator once you factor it. And we're going to leave our answers in factored form for now, even though it's not technically simplified. So now I can combine my numerator, so 5x plus 2, and write it over my common denominator, x plus 4 times x minus 4. And again, it doesn't matter what order you write those two binomials in. If you want to write the x minus 4 first and then x plus 4, that's fine. Okay, so let's do some more complicated problems. So looking at question number 5. So again, the first thing you want to do is factor. So if I factor, factors of 4 that add up to 5 would be 4 and 1. So x plus 4 times x plus 1. Here, this factors into 3 times x plus 1. We're just taking out the GCF. And once I do that, I can see my LCD is 3 times x plus 1 times x plus 4. And so now I'm going to look for what's missing from each fraction from my LCD. So this is missing a 3. And what's missing over here, the x plus 4. So remember to multiply the top and the bottom. So when I do that, 1 times 3 is 3. Over 3 times x plus 4 times x plus 1 plus, and here you're distributing the 5x. So that gives us 5x squared plus 20x all over 3 times x plus 4 times x plus 1. Now I have a common denominator, so now I can add or combine the numerator over my common denominator. So that becomes 5x squared plus 20x plus 3 over 3 times x plus 4 times x plus 1. And if you can factor, again, you're going to want to try to factor. So if we try to do our Swedish fish don't really swim, so 5x squared plus 20x plus 3. So 5 times 3 gives us 15. And that means there are not factors of 15 that add up to 20, so this does not factor. So that means this is our solution. All right, go ahead and see if you can do number 6 on your own. When you're done, you can unpause to check your work. So looking at question number 6, again, the first thing you want to do is factor. So if I factor this, we want factors of negative 12 that add up to negative 4. So x minus 6 times x plus 2. And now I can find my LCD. So my LCD, we have an x minus 6 and an x plus 2. So that means I am missing from this second fraction an x minus 6, and that would mean both denominators would be the same once I multiply this by x minus 6 over x minus 6. So we're going to have to distribute here. So this gives us 1 over x minus 6 times x plus 2. And then plus 3x squared minus 18x over x minus 6 times x plus 2. And then I can combine now my numerator over my common denominator. So 3x squared minus 18x plus 1 divided by x minus 6 times x plus 2. And then again, I want to see if I can refactor this. But if I take 3 and multiply it by the 1, I don't have factors of 3 that add up to negative 18. So this does not refactor, and that's my solution. Go ahead and see if you can do number 7. When you're done, you can unpause to check your work. So here I see I have a greatest common factor that I can take out, which is 5. And then this is the difference of two squares, so 5 times y plus 5 times y minus 5. Over here I have a greatest common factor of 3, so 3 times y plus 5. And that means my LCD, I have a 3 and a 5, so those are our numerical values, and then y plus 5 and y minus 5. So then I want to see what's missing. So this over here, this fraction, the first one, is missing that 3, so I'm going to multiply it by 3 over 3. And over here, we're missing the 5, and we're missing the y minus 5. So I need to multiply this by 5 times y minus 5. And when I do that, here, 7 times 3 gives me 21y over 3 times 5 times y plus 5 times y minus 5. And we're subtracting, so I'm going to make this a plus because I want to remember to distribute that negative. So plus negative 4 times the 5, so negative 4 times 5 is going to be negative 20 times y minus 5 over 3 times 5 times y plus 5 times y minus 5. Now again, you do not want to cancel out the y minus 5 here because remember we multiplied that over here on purpose. We still have to distribute and combine like terms in our numerator. We just haven't done that yet. So I have 21y over, and we can multiply the 3 and the 5, so 15 times y plus 5 times y minus 5 plus, here we get negative 20y, and then minus minus becomes plus, and that would give us 100 over 15 times y plus 5 times y minus 5. Now I have a common denominator. I can go ahead and combine my numerator over my common denominator. So these are like terms right here. So that would give me positive y, because 21 minus 20. So 1y plus 100 over 15 times y plus 5 times y minus 5. And nothing factors out any further, so this would be our solution. All right, go ahead and see if you do number 8 on your own. When you're done, you can unpause the video to check your work. So looking at question number 8, again, the first thing you want to do is factor. So I see a GCF of 3 here. So that's x squared plus 12x plus 35. And then factors of 35 that add up to 12. So that would be 5 and 7. So x plus 5 times x plus 7. And then over here we have a greatest common factor of 6. And 6 breaks down into 2 times 3. So this is 2 times 3 times x plus 5 times x plus 7. And then I can see what's missing. So over here we have the 3, the x plus 5, and the x plus 7. We're missing that 2, so I'm going to multiply this by 2 over 2. For this one, we're missing the x plus 7. So when I multiply that, negative 2 times the 2 gives me negative 4 over 2 times 3 times x plus 5 times x plus 7. Oops. And then we have minus. So I'm going to make this a plus and put the minus here so I don't forget to distribute that negative. So that would be plus, and then negative 3x times x is negative 3x squared, and negative 3x times 7 is minus 21x over 2 times 3 times x plus 5 times x plus 7. And now you can see you have a common denominator. Now that I know I have a common denominator, I can combine my numerator over my common denominator. So when I do that, I don't have any like terms in my numerator, so that just becomes negative 3x squared plus 21x minus 4 divided by, and I can multiply the 2 and the 3, so that's 6 times x plus 5 times x plus 7. And if I try to multiply this times this, negative 3 times negative 4 gives me 12. I do not have factors of 12 that add up to 21, which means I cannot refactor that. All right, go ahead and see if you can do the next one on your own. When you're done, you can unpause the video to check your work. So looking at this one, I cannot factor either of these, so that means the LCD is going to be 3x minus 1 times x plus 1. So that means this I need to multiply by 3x minus 1 over 3x minus 1. And over here, I need to multiply this by x plus 1 over x plus 1. So remember, if you have a binomial times a binomial, you need to FOIL. So we're going to have to FOIL all of these. So let's go ahead and do the x plus 1 times x plus 8 first. So if I FOIL this out, I get x squared plus 8x plus x plus 8. So x squared plus 9x plus 8. Your denominator, remember, we're leaving in factored form, so that's nice. You can just leave it as x plus 1 times 3x minus 1. And of course, if it's a standardized test, I'll probably FOIL that out, but for now, we're just going to leave it in factored form. Plus, now I need to FOIL this other numerator. So x plus 3 times 3x minus 1. So that gives me 3x squared minus x plus 9x minus 3. So that gives me 3x squared plus 8x minus 3 over x plus 1 times 3x minus 1. Now I can see I have my common denominator, so I can combine my numerator over my common denominator. 3x squared and x squared are like terms, so that becomes 4x squared. 8x and 9x are like terms, so plus 17x. 3 and 8 are like terms, so that's plus 5 over x plus 1 times 3x minus 1. And then if I do 4 times 5, I get 20. So do I have factors of 20 that add up to 17? I do not. So that means this is my final solution. And there are some harder problems that we will also get to, but we're going to look at those tomorrow. So that's it.